Okay. Angles of elevation. You will need your calculator to grab that. Okay. We're gonna use SoFaToa to help us today. Okay. So if you were gone last week, this will be a nice little refresh. You've already learned it before, but it might have been a couple years. Really quick, the difference between an angle of elevation and an angle of depression. Okay, the angle of elevation would be an example where, like, somebody's standing on the ground and they're looking up. The angle of elevation is looking up. If you hear angle of depression, that would be where, like, somebody is looking down. Okay, if depression is down. You can kind of think of that's the words and what they mean. That will help you. But what's really cool about the measure of an angle of elevation and an angle of deflection, like, they are actually the same. Okay? And we're going to use that as a tool to help us answer the questions. Okay? We're just going to jump right on. So, number one, a power line is connecting the top of a building to the ground. Okay, so let's go ahead and draw that. Okay, so we have our building. Here's our building. Okay, that's straight up and down. Okay, and then we have a wire that's connecting to the ground. Oh, look at that, a triangle. Okay, so the key is knowing what to label. It says here, power line connecting the top of the building to the ground 260 meters away from the base of the building. So, is X or Y going to be 260? Y. Okay, because it says, the key word there is that it's on the ground. So there's our 260. At what angle is the wire connected to the building? Okay, if the wire is 340 meters long. So we want to find this angle right here. Okay, what do I label 340? The hypotenuse. That is the wire, and that's the length of the wire, 340. So that's kind of the two hardest things here are drawing the picture, making sure that you have it accurate, and the second is picking out what to do. So the best thing I can tell you to do is you're using SoFaToa. Okay, our angle is this angle. So how does 260 refer to that angle? What side is it? Opposite. What about the 340? Hypotenuse. Opposite hypotenuse is sine. Okay, so we're going to do the sine. Do we have the angle? No, we need to find it. So sine of angle x, you can label it whatever you want. It doesn't have to be x. Okay, equals opposite 260 over hypotenuse 340. Opposite over hypotenuse is sine. Okay, in your calculator, do you remember how we find an angle? We have to do the inverse. So what you'll put in your calculator is you'll do sine to the negative first. Okay, that means the inverse. You call it inverse trig. Okay, if you're using an 83, 84, you'll do second sine. That'll give you the negative first. If you're on an Inspire and you press trig, sine to negative first should be an option. So second sine for B, Inspire, do something different. And then put your fraction in there. And you should end up with 49.88. They will round to 49.89 degrees. Okay, if you're not getting that, we probably need to change the settings in your calculator. So if you didn't get that, we just need to get you in degree mode. Yeah, press mode and go down to the fourth line and make sure it's degree. Press go over degree for a second.
Did you have like a calculator class in college or something?
Just as learned as I went. Yep. A lot of times, like in college, they wouldn't even we couldn't use calculator. Now we're finding English. Oh.
Yeah.
Or the have to actually be solved whole operation.
Oh yeah, there's no way I would have done that. I mean, being able to.
What are you
Yeah, look at your denominator. Is that what our denominator is? What I would do is I would make it work out. Okay. All right. Any other questions? All right. We're gonna skip over number 2. Not my favorite question. Number 3. You're going to flip number 3. You're not allowed to skip questions, by the way, if you don't like them. Okay. So we have a sailor, okay, that is looking at a kite. If he looks at the kite at an angle of elevation of 36 degrees, so let's draw that. Okay, so here he is. He's looking at an angle of elevation of 36 degrees. And the distance from the boat to the point where the kite is directly overhead is 40 feet. Okay, now this is a very confusing way to ask this question. So let's reread. The distance from the boat, here's our boat, okay, to the point where the kite is directly overhead. How weird is that? Okay, think about it. If I was reading directly overhead, I would think this, right? I would think this distance directly overhead, right? But think about it, the boat is here, right? And then they ask you, how high is the kite? Well, the height of the kite would be here. Do we agree? Okay. So it's very weird how they asked it. I'm afraid the better, but okay. Okay, so we know that this distance is 40 feet. Very strange way, but we'll figure it out.
You have to draw the boat and the kite or I'm not going to get it.
You have to.
Draw it. Draw the boat and then draw the kite on the other side.
That's a boat? That looks like an anchor.
I think it's.
You asked me to draw a kite or a kite.
Now draw the kite on.
It's fine. You guys are so mean.
I think it looks
Thank
great.
you.
That's a good boat. That's a good boat.
My boat is adorable.
I take that. I take that photo on.
It's a sailboat.
You are a hater.
It's a sailor.
Traffic.
Okay, the most important part is not my picture, it's the map. So let's go. All right.
Oh.
Opposite is x. What's 40? Hypotenuse. Which trig function am I using? Sine. Okay. Sine of 36 equals opposite x over 40 hypotenuse. How am I going to solve for x? What do I do first? Nope. Multiply by 40. Remember, you want to get x by itself. If x is the angle, then you do your inverse. Okay, we're going to put 40 sine 36 right in our calculator. See? Nice for it. You should get 23.5. Make sure you label it properly. Should be feet. I don't feel like that kite's very high.
Yeah, that's
high.
I think it is long.
Because, okay, so here's why. It says the distance from the boat to the point where it's directly overhead. This is overhead. Okay, I can see that. So look at a different way of thinking about number 3. He thinks 40 should have been here.
that's what I thought.
Because it says from the boat to the point where it's directly over. That makes sense too. Okay, so if you did that, did you write that yet? So okay, let's just do that. If you did that, it would be opposite over adjacent, right? So tangent. It's going to be a different measurement. 40 times the tangent 36. So in that case, it would have been 29.1 feet. Okay, so I will make sure that it is very obvious which side. Because that's just not agree. It's not agree. But I like the way you think. Anybody else think that way? No, that's pretty good. Yeah. All right, number 4. Simon is standing on a street corner. His eyes are 6 feet off the ground. Okay, so here he is, 6 feet off the ground. Okay, so
You are involved with
cockroach. Look how tall he is. Okay. Anyway,
What
whatever.
a big boy.
He is. No. All right. He is looking down. Thank you. He is looking down at a cockroach that is on a box that is 1 foot off the ground. Okay, so picture this. Okay, I am not 6 foot by any means, but okay, say I was. Okay, and then I was looking down at a box that was 1 foot tall. I would subtract that foot from the distance that I'm looking down. Are you with me? Okay, so let's change this to 5 feet. Okay, so we're going to subtract that foot off. Okay, now, like I said at the beginning, angle of depression, angle of elevation are different things. If he's looking down at an angle of 40 degrees. Okay, so that angle of depression is not inside the triangle. Okay? But that's okay, because what did I say about the angle of depression and angle of elevation? They're the same. They're the same. Okay? So right here is also 40 degrees. Okay, now it's asked how far is he from the cockroach? Where is that distance at? Where is that distance at? Here's the cockroach. I don't know what they look like. That's the distance right there.
That's why I would think to go there. But it's so like that makes sense.
Yeah.
I just
Because technically, like this doesn't make sense. They're parallel. Okay. Which trig function are we using? Which trig function are we using, group?
to the other side of the
Opposite, adjacent, tangent. Stay with me. Okay, tangent of 40, opposite 5, over adjacent x. I'm going to let you solve by yourself. There's a quick trick that I taught you to solve this. Hope that you remember it.
I wish I would have, because I had a, I'm disappointed.
Remember where I told you you can flip block those? And you can trade them out? Go ahead and do that. So I just flipped my x and my tan 40. You should get 5.95, which would just round to 6. Let's say about 6. Definitely not far enough for me if it was a cockroach.
Apparently there's a cockroach that's so dead at camp. I think I know what cockroach is. I used to have pet Madagascar kissing cockroaches.
I'll leave the 2.
I got them for Christmas for my uncle and I
Yeah.
killed them on purpose.
Yeah. Oh, I would have too.
Why
They
would
wouldn't
you,
even made it home with me.
why would you give
They would have
that?
escaped until
They're like
alive.
this big and they would piss at me and I would freaking die. I just-
Okay. Okay, this one's going to take some focus because we have 2 triangles going on here, so bear with me, okay? We have 2 boats. All right, here's your boats. See, I was going to use my boat drawing for this example, but you had to have a boat.
Well, what would you vote?
Okay, there's boat number 1.
See, that's such a cute logo.
You have to put Donald Trump's.
Okay, there's vote number 2.
I'm gonna check out my
Okay. 2 boats are observed by a parasailer that's 75 meters above the lake. So, here's our lake. Okay, so if the parasailer is 75 feet above, here they are. Here's our parasailer.
which book is he?
Okay, so 75 feet above the lake. The angles of depression are 12.5. So we'll say to boat 1. To boat 1, there's 12.5. And to boat 2 is 7. Look at that beautiful triangle that we just drew.
That's beautiful.
Technically, we have 2 triangles now.
Can you draw a shark in the water?
You're asking a lot,
I got you.
but I suppose I could. Even I think they're all.
Oh, thanks. Do your best.
Yes.
Can I draw?
Yes.
I don't know.
It's a
So
fat
terrible.
shark. Give it some go.
I'm so bad at drawing. Okay.
Who said I was extra?
Okay. We're good there. Right, but we need angles inside the triangle. Okay? Where else can I write 12.5? Right here, because that's also the angle of elevation. So we know that that would be the same. Same thing with the 7 over here.
Okay, so it isn't connected to anything. Just like that.
Okay. It says how far apart are the boats. So would you agree we need to find this distance?
Yes.
Okay. To do that, let's do one triangle and then the other. So let's find x for that distance, and then we'll find y for that distance, and we'll add them. Are you tracking with me? All right, so to find x, we would do what over what? 75 over x, so that's opposite over adjacent, so it'd be tangent. So tangent, 12.5, opposite, adjacent. Okay, then over here, but let's go ahead and set it up. This would be opposite over adjacent. Okay, I'm gonna let you solve. Can you scroll? Hey, check this when you get done. This was Mrs. Cressy. Okie dokie. Logan, you signing up, bud? See you when we see you. Okay, we doing okay getting those answers? Now to get that total distance, we just have to add them up. I don't remember what the answer is. Was it meters? Meters?
Yes.
You should end up with 949.1 total once you add those together. Questions, issues, concerns? Okay, so for my friends who were gone last week, if you missed Sokotoa, hopefully it's coming back a little bit to you. You can watch that online if you need to. I have a video of it. I want you to try number 6 on your own. If there's already a picture there for you, it should be very straightforward. But try number 6 all on your own, please.
Oh, golf is so good. I suck at this. Every time I try to golf, I lose the ball.
That's the shot. So it's easy. The hole is here.
First up here, I would say.
You guys get 173.2?
Yeah.
And that's yards.
How do you get
All right, number 7. We're in number 7 together. Any questions on 6 before I move on? All right, number 7. Now, we're going to be dealing with descending or looking down. So that'll be angle of depression. We haven't really had that yet. After flying at an altitude of 500 meters. Now, what does altitude mean when it comes to a plane?
No one's getting.
Up, down, what else?
How high up the ground it is.
How high off the ground it is. Okay, so our distance off the ground is going to be 500 meters. Okay. Then it says it starts to descend when its ground distance from the landing pad here, okay, is 11 kilometers. Now, wait a second, because we have meters in the first one. So how can we change this into meters? How many meters in a kilometer? 1,000. Okay? So 11 kilometers would be how many meters? 11,000. Good. Okay. So if that happens, you're going to need to make sure that you transfer. Okay? Obviously not on a scale. Disclaimer. It's fine. What is the angle of depression for this part of the flight? Again, right here, angle of depression is there, which matches with what other angle?
Bottom one.
This one right here. Okay, so it's easier to solve for that. Okay, how does 500 relate to my angle? What side is it? Opposite. What about 11,000? Adjacent, still working with?
But can't we just,
Here we just
to find the hypothesis, can't we just do,
well, we're not looking for that side though. We're looking at the angle. If we were looking for the hypotenuse, we could do factor here. Yeah, but we're looking for the angles. We got to. Okay, this one is where you do inverse tangent. So you do inverse tangent of your fraction in your calculator.
Why do we do inverse tangent on this one?
Because you're looking for an angle. So anytime you're looking for the angle is where you do the inverse.
I mean,
Very narrow angle. Should get 2.6 degrees. Again, do not draw this down. Okay, when you come to that, try number 8 on your own. It's very similar to this. Try number 8 on your own. Very, very similar.
are you gonna have that one going? Go for that.
There's a drawing if you want to make sure that your drawing is proper. It's a sledding run, friends, right?
Wait, why would it be like this? Like you're running and then. Maybe I don't understand.
So the vertical drop from the top to the bottom is 276, 276. And then the sledding run, which would be like the length that you would sled on it. Yeah. Yeah. So think about like sledding, you're going down the hill. Yeah, I feel like if they would have said the sledding hill is, that might have made it easier. Yeah, so the sledding hill or the sledding run is the 300 yards.
That's a really long.
Remember you're doing trig inverse on this one. Again, very narrow angle. Should be 5.3 degrees.
You plug it in when it's like that. This is awesome.
Maybe.
How do you plug it in when it's like that?
So you would do sine inverse. So if you're doing 83, 84, so you do second, you would see your keypad. Yeah, so press second sine. And then you'll type in the fraction 27.6 divided by 300. Did you get it?
Hold on.